In this video, we're going to take a look at how we can write numbers in scientific notation. And scientific notation is a form that lets us write really, really big numbers and really, really small numbers much more easily than we normally would have. So if we start to take a look here, we can see that we have standard form, and that's how we usually see the numbers every day. So there's going to be lots of zeros in standard form, either before the decimal or in between the decimal point in the number or at the end of a number. But scientific notation is going to make it a lot easier to write those without having to write all of those zeros. So when we write a number in scientific notation, there are a few different parts that we have. The first is what we call the coefficient. This is the number that's being multiplied by some power of 10. And when we write this, there's always only going to be one digit in front of the decimal point. So that means that this number is always going to be just one digit here. So it could be 1, 2, 3, 4, 5, 6, 7, 8, or 9. But it can't be any bigger than 9 point something. So if I see 10 point or 20 something point, that's too big. So this first number here has to be between 1 and 9, and there's only ever going to be one digit before the decimal point. We can have as many as we want after the decimal point, but there's only ever going to be one beforehand. So that coefficient has to be between 9 and 1. Then it's always going to be multiplied by some power of 10. So we're always going to write some number times 10 raised to what we call an exponent here. So this exponent tells us how many spaces we're going to move that decimal point. So if you remember when we worked with percents and decimals, we always move the decimal point 2 spaces. That's because with percentages, we're dealing with factors of 100. 100 means that we move 2 decimal places because it's 10 to the second power, 10 squared, as we know from our perfect squares. So this is very similar, just instead of only working with 100s, we're going to work with lots of different powers of 10. So that exponent is always going to tell us how many spaces we move the decimal point. It does not tell us the number of zeros. Instead, it tells us how many spaces or how many steps we're going to take when we move that decimal point. And in a minute, we're going to look at how we can convert between these two different types of numbers. But if you look here, we have some examples. So this is an example of a standard form large number. So this is 2,350. So that's a pretty big number. And this is what that number looks like in scientific notation. So you can see we have taken this where we have just one digit before the decimal point. And then everything else that comes after it shows up after the decimal point here. So that 2 is our first digit. We have the 3 and the 5, and we don't need to add the 0 on the end because it's not important. And then we have this exponent here, 10 to the third power. And you'll notice that this is positive. So for large numbers, the exponent is always positive. Then we have a small number, and with the small number, we're going to be able to see the decimal point here. With the big number, the decimal point always starts out at the end of the number, unless we see it somewhere in there. Usually, though, we won't. And we move that decimal point a certain number of spaces to the left to figure out our scientific notation. But for the small numbers, we're going to see all the zeros at the beginning of the number, and we'll see that decimal point. Then we will figure out what that one digit in front of the decimal point is going to be. In this case, it's going to be 7, and we see that here. And then we are going to put that decimal point immediately after that first digit. So we're looking for the number that comes after the last 0. And then we fill in the decimal point, we have everything that comes after it. And here for a small number, you'll see that we have a negative exponent. So negative exponents don't mean that we're dealing with a negative number, like this is still positive 0.072. It just means that we're going to have a really small decimal. We're actually dividing by 10 that many times when we have that negative exponent. But again, the most important thing is that when we move the decimal and we're looking at that exponent, that counts the number of spaces that we're moving and not the number of zeros. So that's a mistake that people make a lot. But again, the exponent tells us the number of spaces that we're going to move, not the number of zeros. So if I look at my first example here, I want to know which of these are properly written in scientific notation. So I'm going to go ahead and label these with letters. And once I have them labeled, I want you to pause the video And in Edpuzzle, go ahead and select each of these that are correctly written in scientific notation. So we want to know which of these have that number between 1 and 9 multiplied by 10 to some power. So go ahead and pause the video and try that now. All right, so now let's take a look at these. So I'm really just going to look at this first number here. So is that a number between 1 and just less than 10? So here we have 4.5 times 10 to the third. That is great. That's good to go. 2.0 times 10 to the negative 7th. Yes, that's good to go. Next we have 65.1 times 10 to the negative second. 65.1 is too big. You can see we have 2 digits before the decimal point here, so that is no good. 9.077, this one we just have 1 digit before the decimal point, so that one works. Here we have 9 times 10 to the negative 6th. Again, we know that that decimal point is going to be at the end, and there's just 1 digit in front, so that one's good. For F, again, the decimal point is at the end of the number if we don't see it, but this one has 2 digits in front, and we only want 1 digit when dealing with scientific notation. For the next one, we have 0.3, and while we do have just one number here, it's not between 1 and 9, so this one is no good. That's too small. We'd have to fix that to put it in scientific notation. And for H, again, we have 1 digit, and that is between 1 and 9, so that one is in scientific notation. So the correct answers here were A, B, D, E, and H. Now we're going to practice with writing some numbers in scientific notation. So again, each time I do this, I'm going to have some number. It has to be a number between 1 and less than 10, so really 1 to 9, multiplied by 10 to some exponent. So if I look at this here, this is a big number. So I know that my exponent is going to be positive. So I can just add that in here so that I remind myself. And when I look at the digits, I'm going to ignore all the zeros for a minute, but I'm going to look at everything that comes before the zeros. And when I write my number that is multiplied by the power of 10, I only want 1 digit before the decimal point. So I'm going to draw a bit of a divider there. So I'm going to have 6. My decimal point's going to go where I've divided that out, and I have 2, and then the rest is zeros, so I'm not worried about that. We know that when we start, the decimal point is at the end of the number here. So now I'm going to count the number of spaces that I need to move to get where I drew that red line. So I'm going to count 1, 2, 3 spaces. Excuse me. So that means that we're going to multiply by 10 to the third power. So to neaten that up a little bit, we're going to do 6.2 times 10 to the third. So that would be our answer in scientific notation. Now we're going to try a small number. All right, so if I look at this, this is a small little decimal. And again, we're going to have our coefficient multiplied by 10 to some power. So since this is a small number, I know that my exponent is going to be negative here. So now I'm going to go all the way through the zeros, and when I start to hit numbers and things get interesting, that's what we're going to pay attention to. And again, I only want 1 digit. So I'm going to have 3.6 here. And now I need to count how many spaces do we move our decimal point. So we count 1, 2 spaces. And since this is a small number, we're going to use a negative exponent. So it's going to be negative 2. So if we put this all together, it's going to be 3.6 times 10 to the negative second. Go ahead and pause the video and try number 3 on your own. All right, so if we look at this one again, this is a big number. So I know my exponent is going to be positive. So we're going to have our number multiplied by 10 to the power, and that's going to be a positive exponent. So now I look at everything that comes before all of the zeros. So even though I have this 0 in the middle here, I'm going to look at where the non-zero numbers stop. So we've got this. And again, we just want 1 digit before the decimal point. So that digit that's furthest to the left. So this is going to be 4.05. And I know my decimal point starts at the end. So now I'm going to count 1, 2, 3, 4, 5 spaces. And since this is a big number, it's going to have a positive exponent. So my final answer is going to be 4.05 times 10 to the 5th power. Go ahead and pause the video and try number 5 on your own. All right, so if we look at this number, this is a small number because it has all these zeros in the front. So I'm going to go until those zeros stop, and we're going to be focusing on this part here. And again, I want the leftmost digit to be the first one before the decimal point. So this is going to be 9.02. And now I just need to count how many spaces to get from that red line, that new decimal point that I put in, back to my original decimal point. So we're going to count 1, 2, 3, 4 spaces. So my exponent is going to be -4 because this was a small number. So we're going to have 9.02 times 10 to the -4th power. So that's how we write the numbers in scientific notation if we're given the standard form. But we also want to be able to go backwards. So if we are given a number in scientific notation, we need to be able to convert that into standard form. So we start by just kind of writing down that coefficient that we see. So I'm going to start with 7.5, but I'm going to write it without the decimal point. And I'm going to put my pencil where that decimal point was, and this is where I'm going to use that exponent. So this is a big number with a positive exponent. So this means I'm going to move my decimal point to the right because I want those zeros at the end of the number. So I stick my pencil right where that decimal point was, and now I count 1, 2 spaces, and draw the new decimal point. This first space here is taken up by the 5, so I don't need to do anything with that, but I do have an extra space here, and that's where I'm going to fill in a 0. So our final answer here is 750, 750. So again, I start where that original decimal point is, and then I move to the right, since this is a positive exponent. If we think about the number line, positive numbers are on the right, and that exponent was 2, so I moved 2 spaces to the right. Go ahead and pause the video and try the next one on your own. All right, so again, we're going to focus on this coefficient. And when there's no decimal written, I know that it's at the end of the number. Again, this is a positive exponent, so that means we're going to have a big number, and we're going to move our decimal point to the right. So I'm going to start with my 8, and I'm going to put my pencil where that decimal point was, and now I'm going to count out 4 spaces because that was my exponent. So I count 1, 2, 3, 4, and I draw my new decimal point. And if I look at each of these, there are no numbers in any of these spaces, so every single one of these is going to get a 0. And we have the decimal point at the end, but since there's nothing after it, we really don't have to worry about it. So our answer is going to be 8 with 4 zeros after it. All right, and if we want to, we put the commas in after the last 3 zeros. That would actually be 80,000. This also works when we have negative exponents as well. So again, we focus on that coefficient first. I'm going to start by rewriting that without the decimal point. And now I'm going to look here. This is negative, so this is a small number. And this means I'm going to move my decimal point to the left because I want those zeros in front. So actually I'm going to move my 233 over to the middle here so we have a little bit more room. And again, for the negative exponent, we move to the left. Negative is on the left of the number line. So I put my pencil in that decimal point spot and I count 1, 2, 3, and draw my decimal point. That first space is taken up with the 2, but the other ones are blank, so I put a 0 in. So this means that my final answer is going to be 0.00233. And we could also, if we wanted to, put a 0 before that decimal point. That would work as well. So again, we have a negative exponent, which means we're going to move our decimal point to the left to get a small answer. Go ahead and pause the video and try the last one on your own. All right, so again, we're going to focus on that coefficient. And here I see another negative exponent, so that means this is going to be a small number going to the left. And I'm going to start by writing out that number that I was given, but without the decimal point. I'm going to remember where it was. And I stick my pencil in that spot, and our exponent here is -1, so I move 1 space to the left and draw my decimal point. And I don't have any extra blanks to fill in. The 1 space that I moved is already filled in. So my answer is going to be 0.408. And again, we could stick that 0 in the front if we wanted to. So this would be 0.408. Notice how that for both of these, even though I had a negative exponent, my answer is not negative. My answers are both positive. They're just small numbers. So that negative exponent means that we're going to have a small answer. Also want to point out that the exponent again does not tell us the number of zeros, but instead the number of spaces that we're going to move the decimal point.